Now we're going to talk about the fundamental theorem of calculus. Sounds like an important theorem in calculus. It's fundamental, and it is. So to introduce that, we're going to determine the value of this definite integral of 2x minus 2 from 1 to 3. So we're going to do this just like we learned last section. If we can calculate the area, if this is non-negative, we have it. So it's an easy graph. The 2x minus 2 is just the line, y-intercept negative 2, slope 2 over 1. So that's what it looks like. We're going to integrate it from 1 to 3, meaning we're going to determine the area under the graph starting at 1, ending at 3. And it forms this nice triangle for us. So the area of this triangle is 1/2 base, which is 2, times height, which is 4. So 1/2 2 times 4 is 4. So this definite integral equals 4. That was easy. We knew that. We could do that for basically any line. The problem is this. What if, say this was 2x squared? Now we have a parabola. It's going to look more like this, and we're not going to be able to figure out the area underneath the curved line. We have no geometric formula for that. So that's where the fundamental theorem of calculus comes in. So the fundamental theorem of calculus says, if you have a function that's, first of all, continuous on an interval, and it says we know that f is an antiderivative, capital F is an antiderivative, or an integral of little f, then the definite integral of f from a to b is the antiderivative at b minus the antiderivative at a. So b is the upper limit still, a is the lower limit. So that might be a little bit confusing, don't know. It'll make sense when you see an example. So here we go. Before we start this, one of the things the fundamental theorem of calculus does is, in the first section you did indefinite integrals. Last section we did definite integrals, and up till now they had nothing to do with each other. Now we're going to see what they had to do with each other. I lost my word there, so that's what we're going to do with that. So here we go. This integral, according to the fundamental theorem of calculus, is the antiderivative. So the integral of 2x minus 2 is use the power rule. Add 1 to the exponent, divide by 2, so that's 1x squared. That's for that one. And then the integral of 2 is 2x. And then to get the value, you just plug in 3 to this antiderivative and minus 1 into the antiderivative. But I'm not going to do that just yet. I'm going to show you notation as we go. When you take the antiderivative, we'll put it in brackets, rewrite our limits now on the right side of the brackets. That's a 3. And then this always means plug the top limit in first, so right into this function. And then minus, plug the bottom limit into this function. And then evaluate. 3 squared is 9, minus 6, minus 1 squared minus 2 is 1 minus 2, which is negative 1. 9 minus 6 is 3. Minus a negative 1 is plus 1. So this definite integral is 4, which isn't surprising because we just did that with the area. So it looks like this works, and it does. Trust me on that. I want to show you one more thing. Your calculators, if you have a calculator, or Wolfram Alpha will do this for you. have the capability of doing definite integrals. So I didn't show you the indefinite integrals because they weren't capable of it. But for definite integrals, you just type in your function into the y equals screen. So y equals 2x minus 2. This is the original function, the one that we're integrating. Hit graph. So we do everything through the graph. Then second calc as usual, second trace. And then go down to 7, which says integral. And it's actually a definite integral. So I'll ask you for the lower limit, which we know is 1. Hit enter. I'll ask you for the upper limit, which is 3. Hit enter. And it actually shades the area for you, which is nice, and gives you the answer right down here, which is 4. And that's it. Sometimes it's not that, sometimes it's off like 0.001, but for a line, it does it very well because it's easy. And that's your introduction to fundamental theorem of calculus. We have a lot more to talk about, but hopefully you get the gist of it.